The first two videos for this chapter provided a foundational understanding of supply and demand. The next two videos will combine them together to allow us to analyze the market equilibrium. The root word within equilibrium is equal, so there's going to be something special about the supply and demand curve when they are equal to each other. In fact, a market equilibrium occurs when quantity demanded is equal to quantity supplied. Graphically, this is where the supply and demand curves intersect. The quantity associated with that intersection point is referred to as our equilibrium quantity, whereas the price associated with that particular equilibrium quantity is referred to as our equilibrium price. So by definition, the equilibrium exists where the equilibrium quantity is equal to quantity demanded and quantity supplied. As far as notation is concerned, the textbook likes to use the subscript E to denote an equilibrium, whereas I have been trained to use an asterisk. Either way, we are all referring to the same thing. Notice that this graph combines both the upward sloping supply curve and the downward sloping demand curve. As we learned before, the x-axis represents quantity, while price is on the y-axis. Again, the equilibrium is where the demand and the supply curves intersect. We use this graph to analyze what happens to the equilibrium price, PE, and the equilibrium quantity, QE, whenever a business decision is made. More on that later in this video. But first, we want to appreciate what happens when the market is not in equilibrium. When we're not in equilibrium, then we're in disequilibrium. There are two types of disequilibrium. One is called a shortage, which occurs when the market price is below the equilibrium price. If companies charge a price that is too low, then consumers are going to be very interested in this product. And so quantity demanded is going to be quite high. On the other hand, at a relatively low price, firms are going to be disincentivized from producing their product, and so quantity supplied is going to be relatively limited. Notice that we are not in equilibrium because quantity demanded is greater than quantity supplied. Since more people want to buy this product than companies actually produce, this leads to a shortage. In the real world, this means that the product is sold out and back-ordered. For example, Nike sometimes produces small quantities of limited edition shoes and charges relatively low prices. How do we know that Nike charges too low of a price? Well, plenty of people wait in line at retail stores and then resell these shoes online for more than they paid for. In this sense, Nike is leaving money on the table, but is able to produce a lot of hype for these limited edition shoes. An economist would look at this situation and recommend that Nike increase its price to the equilibrium price. Surely some consumers might be priced out of the market, but Nike could still sell more shoes at a higher price and therefore earn more profits. We'll talk about the economic impact of this in a future chapter. So what happens when prices are too high? In that case, we get the opposite of a shortage, which is a surplus. Suppose that companies charge a price higher than the equilibrium price. Just like with shortages, we are not in equilibrium since quantity supplied is not equal to quantity demanded. But this time, quantity supplied is greater than quantity demanded given the artificially high price, which means that companies made more product than consumers want to buy. In the real world, you would see this anytime you go to a department store and you find a clearance rack, or maybe you shop at an outlet mall where the products are heavily discounted. To resolve this surplus, economists would recommend that the companies lower their price in order to attract more customers to buy that product. This would also limit quantity supplied so that companies don't have excess inventory. In the lecture slides I posted on Moodle, you should have a table that looks something like this in a few slides. However, what I included was the final version of this table. So what I'm going to do is start off with the bare bones and then discuss where the different cells in this table are coming from so that by the end of this video, you will appreciate the components of the fully completed table. The objective of this table is to summarize what happens to equilibrium quantity and equilibrium price when there is a shift in the supply curve or the demand curve or even both. To start us off, this table fills in the cell when neither curve shifts. This is boring because nothing is happening, so there's no change to the market equilibrium. So let's move on and analyze the scenario of a shift in the supply and demand graph. So what we ultimately want to do is to take a look at what happens when there is a shift and how that influences equilibrium price and equilibrium quantity, starting with a shift in the demand curve. Let's suppose that we're starting with the initial equilibrium, which is associated with point A in the graph. The initial equilibrium quantity is then Q0, and the initial equilibrium price is P0. What happens when there's an increase in demand? Remember we said that this is associated with a shift in the demand curve to the right. For example, if this is the supply and demand for apples, and a medical research study finds that eating apples makes you less likely to get sick, then the increased popularity of apples is going to shift the demand curve from D0 to D1. Similarly, a raise at work will increase the demand for normal goods like clothes, whereas a furlough will increase the demand of inferior goods like ramen noodles. In each of these cases, the increase in demand will lead to an increase in both the equilibrium quantity and the equilibrium price. In other words, not only will these scenarios result in more consumers wanting to buy the product, but they are also willing and able to pay a higher price for these products. On the other hand, a decrease in demand means that the demand curve shifts to the left. For example, the demand for Starbucks coffee decreases when the price of a substitute like Dunkin' is cheaper. On the other hand, the demand for peanut butter decreases when the price of a complement like jelly gets more expensive. In these cases, the original demand curve D0 shifts to the left and becomes D2, resulting in a lower equilibrium price and equilibrium quantity. With a reduction in demand, less consumers are willing to buy the product, and only if the price is lower. Now let's connect our initial table with what we just discussed. Notice that supply was unaffected by the scenarios presented in the previous slide. Whenever demand increased, the demand curve shifted to the right, which resulted in a higher equilibrium quantity and equilibrium price. But when demand decreased, the demand curve shifted to the left, which resulted in a lower equilibrium quantity and equilibrium price. So now that we have the left column filled out, let's consider the top row in this table. Again, let's start by identifying the original equilibrium in this graph, which is denoted as point A and results in Q0 as the equilibrium quantity and P0 as the equilibrium price. What happens when there is an increase in supply? Remember we said that this is associated with a shift in the supply curve to the right. For example, lower input prices like the cost of labor or steel will increase the supply of cars. This would lead to a shift in the supply curve from S0 to S1. Finally, a decrease in the price of BMW's 3 Series sedans will increase the supply of BMW's X5 SUVs. In each of these cases, the increase in supply will lead to an increase in the equilibrium quantity, but at a lower equilibrium price. In other words, the increased production means that more product will be bought and sold, but the extra production means that the price must fall. On the other hand, a decrease in supply means that the supply curve shifts to the left. For example, a natural disaster could cause a power outage, which would shut down the production of certain products like cars. Alternatively, the supply for Apple iPhones decreases today if Apple expects the future price to increase in the future for whatever reason. Later this semester, we will study how companies going through bankruptcy could exit a market, meaning that less firms exist and so the market supply for their product decreases. In these cases, the original supply curve S0 shifts to the left and becomes S2, resulting in a lower equilibrium quantity but a higher equilibrium price. With a reduction in supply, products become more scarce and so quantity decreases but prices increase. Now that we've illustrated shifts in the supply curve, let's check in with that table we have been working with. Notice that demand was unaffected by the scenarios presented in the previous slide. Whenever supply increased, the supply curve shifted to the right, which resulted in a higher equilibrium quantity but lower equilibrium price. However, whenever supply decreased, the supply curve shifted to the left, which resulted in a lower equilibrium quantity but a higher equilibrium price. In each of our scenarios so far, we have isolated a shift in either the demand curve or the supply curve, but both curves can actually shift simultaneously. We need to be extra careful with our analysis whenever that happens. Let's suppose that the demand for SUVs increase because gas, which is a complement to a car, becomes cheaper. At the same time, the supply for SUVs decreases if a natural disaster were to shut down the production of cars. In these cases, the demand curve shifts to the right and the supply curve shifts to the left. Notice that both graphs in this slide illustrate an increase in demand and simultaneous decrease in supply. Yet they don't tell a consistent story about how these simultaneous shifts affects the market equilibrium. Now that both curves are shifting, we compare the initial equilibrium, denoted as A, with the final equilibrium, which is labeled with the letter C. The graph on the left shows that equilibrium quantity ultimately increases from Q0 to Q2, and the equilibrium price ultimately increases from P0 to P2. In contrast, the graph on the right shows that the equilibrium quantity actually decreases from Q0 to Q2, but we have a similar increase in equilibrium price from P0 to P2. So what's happening here? Notice that the graph on the left has a relatively large gap between the two demand curves and a relatively small gap between the supply curves, whereas the graph on the right has a relatively large gap between the supply curves and a relatively small gap between the demand curves. Now that two curves are simultaneously shifting, the final equilibrium depends on which shift is larger. This is why the impact of the shifts on equilibrium quantity is ambiguous. When the demand curve shift is larger than the supply curve shift, like with the graph on the left in the previous slide, the demand effect dominates the supply effect so that the equilibrium quantity ultimately increases. Since an increase in demand and a decrease in supply both lead to a higher equilibrium price, it should be no surprise that the combination of the two definitely lead to a higher equilibrium price. Notice that the graph on the right of the previous slide illustrated a larger shift in the supply curve versus the demand curve. As such, the supply effect dominates the demand effect so that the equilibrium quantity ultimately decreases. Again, both the increase in demand and decrease in supply puts upward pressure on the equilibrium price. Just like with the previous two slides, we have both curves shifting in the graphs presented here. Also, the demand curve is shifting to the right just like before. But in this case, we also have an increase in supply, perhaps because the steel used to make cars becomes cheaper. As with before, we focus our attention on the initial equilibrium A and the final equilibrium C. Now, the pricing effect is ambiguous. When the shift in supply is larger than the shift in demand, like in the graph on the left-hand side, the equilibrium price falls from P0 to P2. However, the equilibrium price increases from P0 to P2 when the demand curve shifts by more than the supply curve, like with the graph on the right. Notice that in both cases, equilibrium quantity increases from Q0 to Q2. Coming back to this table, we can see that equilibrium quantity increases whenever either the demand curve shifts to the right or the supply curve shifts to the right. So when they both happen, equilibrium quantity is surely higher. However, the price effect depends on which shift is dominant. Again, when the supply curve shifts by more than the demand curve, as in the graph on the left in the previous slide, then the equilibrium price will ultimately decrease. On the other hand, the equilibrium price will ultimately increase if the demand curve instead shifts by more than the supply curve. Using a similar logic, we can now see how we got the final table that is found in your version of the lecture slides. When the demand curve shifts to the left, but the supply curve shifts to the right, then we expect that the equilibrium price will definitely decrease. But the effect on equilibrium quantity will be ambiguous and depends on whether the demand effect dominates the supply effect or vice versa. Finally, if both curves simultaneously shifted to the left, then equilibrium quantity will for sure be lower, but the impact on equilibrium price depends on which curve shifted by relatively more. This video outlined how shifts in the supply curve or demand curve, or even both, impact the market equilibrium. The next video will provide a mathematical example of a situation in which both the supply and demand curves shift. Feel free to email me with any questions that you have.